All right, so today we're going to look at proving triangles similar by SSS and SAS. So these are the last two ways we prove triangles similar. The first one, again, was AA. So we're going to bring back SSS, but this time it's a little bit different. So remember, SSS stands for side, side, side. But for similarity, the sides are not going to be congruent. The sides are going to be proportional. So as long as the sides are proportional, then the triangles are similar. Now, how do we figure out which sides to match up if we don't have a similarity statement and we're checking to see if they're similar? This is when I use the shortest, longest, last method. So I match up my shortest sides to each other, then the longest sides to each other, and then the last will get paired together. Notice I used a circle for the shortest, a rectangle for the longest, and I left the last one blank. I'm going to continue on with that note-taking skill in example 1. In example 1, it says, is either triangle DEF or triangle GHJ similar to ABC? So we're going to do two separate problems. We're going to look at DEF and compare it to ABC. Then we're going to do the same thing. We're going to look at GEF and compare to ABC. So that means we're doing this 2 times. I broke my paper in half because I'm going to separate my work. So up here, this is going to be for triangle DEF. So the question is DEF similar to ABC? So I'm going to start by circling, and I'm looking at ABC here is the main one. I'm going to highlight that one. So this triangle is going to be included in both of our problems. Remember, order matters. And for similarity, we want to check and set up our proportions correctly. So we are going to put the image over the pre-image. So remember, it's triangle ABC. Is it similar to DEF? So here we go. I circle the smallest side in the pink triangle, and I'm only looking at the second triangle here. I'm going to circle that small side. I'm going to then go back and circle the longest sides of each, leaving the last 2 sides not marked. All right, now I'm going to create my ratios. So here again, I'm going to go from 8 to 6, circle over circle. Is that equal to the next one? So now we're going to go again from the pink to the plain one. So 16 over 12. And then last but not least, 12 over 9. Now that we have all 3, we're going to take it one next step and we're going to simplify. So when I simplify these fractions, they can reduce down to 4 over 3. 16 over 12 is again 4 over 3. And 12 over 9 is 4 over 3. Since it's the same number every time, that means that they are all proportional for each side. So looking now at triangle ABC and DEF, are these two triangles similar? And are they similar by what we know? Now remember, we have shortcuts. Is it AA, SSS, SAS? What were we using? So here we're using 3 sides we're comparing to see if it works. So this is similar by SSS. So to make that statement, I'm going to write triangle ABC is similar to triangle DEF. Remember, order does matter. I'm using the order that they gave me by whatever theorem or postulate we are using. All right, so now we have to finish the second part. We have to check, is ABC similar to GHJ? So again, I'm just organizing my work. I'm labeling that work. Now, since I'm already using that method of circling, putting a rectangle and leaving the last blank, I'm going to really be able to use that work again easily. So I'm no longer looking at the triangle in the middle. I'm looking at the triangle at the end. So we're going to circle the smallest number of that triangle. We are going to put a rectangle around the longest, leaving the last side blank. So now I'm going to compare ABC to GHJ. To make this ratio, it's going to be 8/8. Is that equal to 16/16 and 12/10? Again, I have triangle ABC on the top for this. Now we're going to reduce. 8 divided by 8 is 1. 16 divided by 16 is 1. 12 divided by 10 is 6/5. That's not the same. They're not equal. So since I don't have the same numbers each time, triangle ABC is not similar to triangle GHJ. You want to make a statement after all your work. All right, so now we're going to move on, continuing using our side similarity, and we're going to figure out missing pieces, missing parts. So here it says find the value of x that makes this similarity statement true. Remember that this similarity statement provides a lot of information. This information that it provides to us tells us what we can match. Remember, it tells me sides that match. I can't tell what sides match just by looking at the picture. I need that similarity statement to help me. All right, so I'm going to go in and highlight certain sides. So I have AB is the first side. That matches DE. Then going in again, BC matching EF, making the last two sides match. Now remember, we're going to create a proportion. We only need 2 pairs of sides. So we can choose what sides we want to match. All right, so I'm going to match 12/4. So those are my orange sides right there. And set that equal to 18/x minus 1. I chose not to use the sides I didn't highlight. You could have, and you could have paired it with the orange sides or the yellow sides. It's up to you. I chose to go with the variable that had a little bit less work involved. All right, so now we're going to cross multiply. So in this direction, 4 times 18 is 72. Okay, and then in this direction, we have 12 times x minus 1. It becomes a distributive property on our right-hand side, so we're going to distribute. And now we're going to solve. So we add 12 to both sides. So we have 84 equals 12x. Divide both sides by 12, and x equals 7. All right, let's go on to our next page. All right, so here we're going to have our side angle side similarity, which we call SAS. Again, in this time, our sides are proportional. Our angle is congruent. So what's happening here is we have to have a side followed by an angle followed by a side. Now, the angle in both triangles need to be what? they need to be congruent. The sides from one triangle to the next, these have to be proportional to each other, and these have to be proportional as well. So we're going to see what that looks like. All right, so let's look at the first example. All right, the numbers are kind of small, so we're going to label that a little bit darker. All right, so let's put a curve marking at these two angles here. This side is 5. This side is 10. Over here is 10, and over here is 20. Make sure you put that on your figure a little bit darker so you can see. All right, so we are going to still use our method of shortest, longest, last. In this case, we only have two sides, so we're going to go from shortest to longest. So we're going to provide a check. All right, so in our first example, we're going to circle our smaller sides, our shorter sides. All right, so we have 5 to 10. We're going to write that as our fraction. So we have 5 over 10. Okay. And we're going to simplify whenever possible. So what is 5 over 10? Okay, 5 over 10 reduces to 1/2 or 0.5. I like to keep it a fraction wherever I can. All right, then remember we're spelling out side, angle, side. So this is our side. Next comes our angle. Do the angles in both our triangle have the same value? In this case, they do. How do I know that? Right, the curve markings tell me that we have the same value. So I'm just going to write congruent angles. Check. Because there's no value to write, the curve marking does the job for me. Now we're checking the last pair of sides. So I'm going to put a rectangle around them. Again, since we went from left to right, doing the same thing, we're going 10 over 20. Can it be reduced? And the answer is yes. It's going to reduce down to 1/2. So since I have proportional sides, meaning both these numbers end up being the same, and the included angle sandwiched in between is congruent to both triangles, then these two triangles are similar. And I can write that by saying triangle ABC is similar to triangle DEF by SAS. Do not forget to include which theorem or postulate you are using to support your work. So you want to make sure you have that statement. All right, so now we're going to look at example number 2, doing the same process. So I'd like you to sketch your picture, circle your shorter side, box in your longer side, and check the angles. Are these two triangles similar? All right, so let's look at our work. I'm going to circle 4 and 9. I'm going to circle 4 and 6. Box in 9 and 8. And we're going to create our proportions, or fractions, sorry. So we have 4 over 6. We can reduce that down to 2 over 3. All right. Do the angles in both triangles have the same measure? Sandwiched in between? They do. They're both 35 degrees. So they're congruent. I'm going to put a check. And then the last pair is 8 over 9. That cannot be reduced, so I'm just going to actually write 8 over 9. So we can see that we have 2/3 and 8 over 9. Do those numbers match? Does 2/3 match 8 over 9? No, they do not. So since these do not match, the triangles are not similar. So I'm actually going to write myself that note. Not matching, which means not proportional. So because they're not proportional, are these two triangles congruent? Oh, sorry, similar. And the answer is no. So triangles are not similar. Again, I like to use our symbols wherever possible. All right, so at the very bottom of our paper, I have a recap. These are our 3 ways we can tell our triangles are similar. So we have by AA, SSS, and SAS. Remember, angles in all of these are congruent. Any pairs need to be congruent, where the sides are proportional. All right, so we'll practice more. Make sure you write down all these pictures. Make sure you have the markings. Very important to pay attention to what matches what, from angles to sides and all those combinations.